Welcome back to Through Inquisitive Kids. My name's Karen, and I'm one of the recorders on this channel. In this lesson of the grade 7 course, we will be beginning Unit 5, which will be all about linear equations. Now, this is a quite lengthy but very important unit. So, what I suggest is to take notes. As you go through the lesson, bring a notepad and a pen with you and maybe some graph paper when you have to solve the problems. Pause the video to do the practice and you should be fine. So let's dive into the lesson. Introduction to linear equations. Understand the properties of linear equations and finding relationships between values in word problems. As you can see, our unit is quite long and each lesson is split into a few parts. So this is the first lesson, Introduction to Linear Equations, Part 1. Part 2 will be all about the basic properties of linear equations, which will be coming up soon. So if you would like to stay tuned for that, be sure to click the notification bell next to the subscribe button. Learning goals. Understand the concept of linear equations. Able to write linear equations according to the equivalent relationships in word problems. Let's first play a game. If you multiply the teacher's age by 3 and then subtract 17, you get a result of 73. Can you find the teacher's age? And how do you do it? Pause the video and ponder for a moment. You don't know the teacher's age, but how can you find it based off of the information you're given? So that after learning about linear equations, is a problem you can solve quickly. Okay, so this is Karen, and this is her friend. So her friend says, Karen, I can find out your age. Really? What is the result of multiplying your age by 2 and then subtracting 5? 21. So you're 13 years old. So how does she know? Let Karen's age be X years. Therefore, multiply subtract 5 can be expressed as use X in an algebraic expression. So that's 2x minus 5. And then the equation would be 2x minus 5 is equal to 21. Here what we did is we don't know Karen's age, so my age. Okay, I'm not actually 13 years old at this moment, but yeah. So this other girl named Karen, her age we don't know, so we're going to call it X, replacing it with a variable. And then we can use the information given in the problem and convert it into an equation. In that equation, we can then solve. Here, let's look at another example of where linear equations are used. Carmen, so he is another recorder on this channel, planted a sapling. When he planted it, the sapling was 40 centimeters tall. After planting, the sapling grew about 15 centimeters per week. After how many weeks would the sapling grow to be 1 meter in height? So this is a sapling when planted, 40 centimeters, and this is how tall it is after a few weeks, 1 meter or 100 centimeters. This is after X weeks. So let the sapling grow to be 1 meter after X weeks. Remember, usually the unknown value, which in this case is a number of weeks, we can set as a variable. And then the equation we get is 40 plus 15x is equal to 100 because we start with 40 and then we plus 15 centimeters per week or per x, so 15x, is equal to 100. The area of a rectangular park is 5,850 meters squared. If the difference between its length and its width is 25 meters, then what is the length and what is the width? Here we have a rectangle, and first it's always really helpful if you can draw a model of this picture. And creating equations and drawing diagrams are all called making models. An equation is just a mathematical model of a word problem. So here we have a rectangle. It's a park, and its width is x meters, and its length is x plus 25 meters. And here, there are two unknown values, the length and the width, right? But we want as less variables as possible. So in order to do that, we're trying to make less unknowns. And for example, we can represent both the length and width with x. So this is x and this is x plus 25. Let the width of this park be x meters. Then the length of the park is x plus 25 meters. Therefore, the equation that can be obtained is, we know the area, and we have set the length and the width. So we know x times the sum of x and 25 is 5,850. Discuss. Are there any equations you're familiar with in the equations obtained above? Which are they? Think about the answers to these questions in your head as I read them. Number 2. What are the similar characteristics of 2x minus y is equal to 21 and 40 plus 5x is equal to 100? As you can see, both x's, they both have x, so they both have one variable, and everything else is either the coefficient or a constant value. What conditions are needed to be met for an equation to be a linear equation? So both of these are linear equations. Using the characteristics that you may have observed, what do you think are the conditions that need to be met for an equation to be a linear equation? Think about this. And is this 22 over x minus 22 over x plus 1 equal to 1/5? And x times x plus 25 is equal to 5,850? Are these two equations linear equations? So in other words, do they meet the characteristics and the conditions you have for numbers 2 and 3? Concepts learning. The definition of linear equations. So in a linear equation, it only contains one variable. All algebraic expressions are whole expressions, and the index of the variable is always 1. So its exponent is always 1. Such an equation is called a linear equation. Okay, so let's go back. Now that we know the concept and we know the definition of linear equations, is this equation a linear equation? Remember, it says that all algebraic expressions have to be whole expressions. And whole expressions never ever have a variable on the denominator, meaning that no, this is not a linear equation, but this is a linear equation. Okay, you might want to take some notes. All right. Determine whether or not the following are linear equations. And number 7, I will go over with white. Okay. So number 7 is 2 over x minus 7 is equal to 4. Okay, what answers did you get? So the second one is a linear equation, so is the third one, the sixth one, and the 8th one. Let's look at each of these. So the first one does not work because remember, its index is 2. The index of the variable has to be 1. Here it is a linear equation because it meets all of the conditions and the definition. This is also a linear equation. X plus y is equal to 1 is not a linear equation because it contains two variables. Number 5 is not because it does not have an equation sign, an equal sign. It is greater than, and that means that it is not equal. Number 7 is not because it is not a whole expression. X, the variable, is on the denominator, so that means it's not whole. And number 8, let's look at number 8. You might first think that pi is another variable, but remember it's not. It's just a funny symbol. Pi is still a constant value. It's still a number. So pi x is equal to 12 is still a linear equation. So if you're determining whether an equation is linear or not, you'll first have to simplify it. Always simplify it first and then see if it satisfies the following three requirements. 1, it contains one variable. 2, has a variable with an index of 1. And 3, it is a whole expression. Let's do some practice. If 2x to the m minus 3 power plus 4 is equal to 7 is a linear equation about x, so meaning x is the variable here, what is the value of m? So let me walk you through. Because we know it's a linear equation, then let's look at the definition of the linear equation. Okay, so you can always flip back to your notes that you took earlier. The definition of a linear equation, it says one part of it is that the variable has to have an index of 1, meaning that the index of x has to be 1. Therefore, m minus 3 has to be equal to 1. So m is equal to 4. Let's do some step-up training. If x to the k minus 1 power plus 21 is equal to 0 is a linear equation, then what does k equal? Well, again, same concept as last time. K is equal to 2 because 2 minus 1 is equal to 1 and x has to have an exponent of 1. If x to the absolute value of k power plus 21 is 0, then what does k equal? Well, k has to equal 1 or negative 1 because remember, x's index has to be 1. So we're basically saying the absolute value of k is 1. Therefore, k can do 1 or negative 1. Remember, a linear equation is an equation that contains only one unknown or one variable, and the coefficient of the unknown is not equal to 0. Okay, so this is a reminder as we move on to problems 3 and 4. I want you to pause the video first and then challenge yourself and see if you can solve them. Okay, did you get an answer or did you not? So if k minus 1 times x to the absolute value of k power plus 21 is equal to 0, then what does k equal? This has another step to the previous problem. Here, x has a coefficient. Remember, the coefficient of the variable is not equal to 0. So let's see. X here, so k right now can first be 1 or negative 1. So that already satisfies one condition, which is that the index of x is equal to 1. But remember, k's coefficient cannot be equal to 0. So if k was equal to 1, 1 minus 1 is equal to 0, and then the coefficient of x would be 0. So that would not work. Therefore, k has to be equal and only equal to negative 1. What about this number 4? If this is a linear equation, then what does k equal? Remember, it contains, so a linear equation only has variables, one variable that has a power of 1. Here we have x to the second power, which is something that has to be either canceled out after simplification. In order for that to be true, k plus 2, so its coefficient, has to be equal to 0 for it to cancel out. Therefore, k has to be equal to negative 2. The definition of solutions to linear equations. In the Guess My Age game, when we were told that the result of the calculation is 21, the equation we can list is 2x minus 5 is equal to 21. And our solution is 13 years old. Since when x equals 13 allows both sides of the equation to be equal, 13 is called the solution of 2x minus 1 is equal to 21. So solutions to linear equations are the values of the unknown that equates the values on the left and right sides of the equation. Example 2. Check if x is equal to 1 is a solution to the following linear equations. Because the first one, remember, is not linear. All you have to do is substitute. So first substitute x is equal to 1 into this first equation. If we substitute it into the left side, we get -1, and the right side is also equal to -1. And since -1 is equal to -1, then x is equal to 1 is, in fact, a solution to this linear function, to this equation. Okay, remember in mathematics, you always have to be precise with your vocabulary and language. And for the second one, you solve to the same steps as one. All you have to do is substitute. So the left side would be 3 and the right side would be 3. So our final answer for number 2 is yes, it is a solution. Method conclusion. To judge whether a number is a solution of an equation according to the definition of the solution of the equation, just substitute this number in place of the variable and see if the values on the left and right sides of the equation are equal. If the left side is equal to the right side, then this number is the solution of the equation. Otherwise, this number is not the solution of the equation. Practice. Which of the following has the solution of x is equal to -2? And 2. If x is equal to 4 is the solution to the linear equation ax is equal to 8 about x, then the value of a is blank. Pause the video to find your own answers. The answer to the first problem is C, because if you substitute all of these in, then you find that C is the only equation where both sides will remain equal after substituting x is equal to -2. And for the second one, you also just have to substitute x is equal to 4. So substitute x is equal to 4, and then a will have to be equal to 2. Listing linear equations in word problems. Example 3. According to the following questions, set the variable and list the equation. A square is surrounded by a wire with a length of 24 centimeters. What is the side length of this square? Well, first, we don't know the side length of this square. So our first step is to set the variable. And the variable is often the unknown. So let the side length of the square be x centimeters. Here's the equivalent relationship we can get from the problem. The square side length times 4 would be the total perimeter, since each side length is the same. The equation we can get is 4x is equal to 24. Number 2. A computer has been used for 1,700 hours and is expected to be used for another 150 hours per month. After how many months has the computer been used to reach the specified maintenance time of 2,450 hours? First, we need to assume that the computer will be used for 2,450 hours after X months, right? It says after how many months, that's the question, so X is the number of months. The equivalent relationship is the already used time, and the expected use time would be the total maintenance time of 2,450 hours. Our linear equation is 1,700, that's the used time, used hours, plus 150x, because 150 hours per month, is equal to the total 2,450. Now, students, please think critically. How do we convert to a word problem into an equation problem? And what is the basis of listing linear equations? What is that usual set of steps, that gist of listing linear equations? Well, we first start with a word problem, and by finding the equivalent relationship and setting the unknowns, we get a linear equation that we can solve. Analyzing the quantitative relationship in word problems and using the equivalent relationships to list equations is a method to solve word problems with mathematics. Now let's do some practice. Kaylee spent $48 to buy a book and used exactly 12 bills of $1 and $5 when paying. Assuming that the number of $1 bills is X, then the correct equation to describe the scenario listed below is A. Okay, so here we have X, which is the number of $1 of $1 bills. And then we plus the amount of bills, which is 12 minus the amount of bills, which is 12 minus x, and then each of those bills are worth $5. So 5 times the difference of 12 and x, it has a total of $48. So it's in a soccer round robin match, so that's a type of scoring system, with 12 teams, so every 2 teams need to play one game. It is stipulated that 3 points will be awarded for a win, 1 point for a draw, and 0 points for a loss. The number of games won for a team is 2 more than the number of games lost, and their end result is 18 points. How many games did the team lose? Suppose the number of games lost by the team is X games, then the number of games won is blank, and the number of games tied is blank. The equation we can write based off of the equation is blank. Okay, so we know that there is a total of, there are X games lost, but it says here that the number of games won is 2 more than the number of games lost, so that would just be X plus 2. The number of games tied would be 9 minus 2x, and the equation is, so 3 times x plus 2 plus 9 minus 2x is equal to 18, because we know for every one game that was won, we are awarded 3 points, and for every tied game, which is 9 minus 2x, we are awarded 1 point. So our end points are 18 points. So this is the equation we can list. Class summary. Today we did the introduction to linear equations. We will talk through the definition of linear equations, the solutions of linear equations, and setting up linear equations to go with word problems. Okay, so again, today we understood the concept of linear equations. We were able to write linear equations according to the equivalent relationships in the word problems we encountered. Today was a longer lesson, but that's because this is so important. When you walk out of this course, one of the main things that I want you to have learned by the end of it is linear equations, how to use them in word problems, and all of that. And this is just going to become more and more complicated, but at the same time more and more fun, more and more interesting in the future. So remember, stay inquisitive, and I'll see you next time.